suppose we had this type of a function. And that is all the rest that I would like you to draw. Don't draw anything after that, okay? I'll tell you when you would start drawing again. Yes, it does. So, yes. There's not mice anymore. Get rid of them. Okay. So, if I rotate that around the y-axis, there's a problem. And here's the problem. What method have we learned so far that you would like to use to find this volume? The washer method, right? If you like to draw a rectangle, you would expect to draw a horizontal rectangle. You're going to rotate that around. And right now you're feeling pretty confident. You're like, yeah, this seems like a reasonable method to use. A disk method won't work because it has a hole in the middle. Okay? You wrap this part around here, you can see that you sure do end up with that washer shape, right? What's that? Yeah. I mean, it connects out here, it connects at the bottom, but there's, that hole in the middle, okay? So here's the issue, and this is what you have to see. If you don't see this, you'll get 2 problems wrong on the test, I promise you. Do you agree that that refers to my inside radius? And that distance is my outside radius? Okay. What is used to determine my inside radius? Right, okay, that's the formula, but what is actually used to determine the length of little r? The function, right? So the little function, or the little radius is determined by the function, so I would square that. What is used to determine the large radius? The function as well. And so when you subtract those, what's going to happen? You'll get 0. So when the same function determines your inside radius and your outside radius, the washer method is no good. Just like before when we were talking about area between 2 curves. And we looked at this area and we said, well, you could do top minus bottom. But here when you did top minus bottom, we said that's no good because the top and bottom are the same. So instead, we had to, draw them like this. Same thing happens with washer method. Sometimes it falls apart. Exactly, yeah. If you had 2 separate functions, it would be a totally different scenario. Say you had a curve that looked like that. You had another curve that came down there. Washer method is totally legal. But the same function is being used to determine the inside and the outside radius. When you subtract them, they're gone. Now, I'm not telling you guys on the test to use the cylinder method. You have to understand when that situation comes up. You have to be able to look at it and say, oh, it isn't going to work to do the washer method. If you can't see that, you'll get the problem wrong. So, let's talk about the other option. And it is a great option. Now you can draw this. Instead of drawing a horizontal rectangle, I will draw a vertical rectangle. Now that's contrary to what you're used to because if you're rotating around the y-axis, you usually think, well, I'm going to draw a horizontal rectangle. Here's what I'm going to do. I'm going to take that rectangle and I will rotate it around the y-axis. The question is, what happens when you take a really thin rectangle and rotate it about a specific radius? You get a shell. Kind of like if you've ever shot a gun and there's a casing or a bullet that comes out, right? The casing for the bullet. and maybe the top doesn't have a cover on it, the bottom does, right? And so if you slice the bottom off, you would get that shell casing. It would have nothing on the top or the bottom. Or say, for example, you open up a soup can, and let's say you cut off the top and you cut off the bottom as well. You're gonna have a really really thin piece of metal that goes all the way around. Correct? That's what we're getting. So we're getting this really thin shell that goes all the way around. We don't want just that one shell. We want to stack a bunch of shells inside one another. You don't have to continue to draw this, but I would encourage you to try to visualize what I'm trying to accomplish. You see how these will continue to stack inside of each other?